All right, folks, it's Bass Action back in action here. In this video, we are going to talk about all the properties related to rhombi, which is the plural of rhombus, and all of the properties related to squares. In class, we'll do some more work with actually working and finding values, but for right now, we just want to get these properties under control. So for starters, let's take a look at our rhombi or our rhombus, all right? Now, a rhombus is a parallelogram, so first and foremost, a rhombus and all the rhombi will have all of the parallelogram properties. Remember, we're going to abbreviate that p-gram, so all the parallelogram properties. That means that, let's just quick review those. The opposite sides are going to be parallel, both pairs of those. Both pairs of the opposite sides are going to be congruent. We know that the opposite angles, both pairs of opposite angles in the parallelogram will be congruent, and the diagonals are going to bisect each other. So that's going to take care of our parallelogram properties. Oh, also the consecutive angles in the parallelogram will be supplementary, but that's really less of a parallelogram property and more of just parallel lines. So let's go on to things that are specific to rhombi. Now, the definition of a rhombus, and you might want to jot it down, but it's probably less important. The definition of a rhombus is that all four sides are going to be equal. So our main property related to a rhombus, this first significant one, is that it has four congruent sides. So we can go ahead and we can mark those in our picture, those four congruent sides. The next thing that we're going to have related to a rhombus, and if you can draw a good rhombus, and I'll show you in class how to do that, the next one is that the diagonals, in addition to bisecting each other that they do because of the parallelogram, those diagonals are going to be perpendicular. So we can always put a nice right angle in there on our diagonals. Now let's go ahead and mark our bisecting from our parallelogram properties so that we can just have that in there. Remember, the outsides are going to have the single tick marks. We need a different set of tick marks for this diagonal and a different set for this, because clearly those diagonals are not congruent to each other. The next thing that we're going to have is that the diagonals are going to bisect the opposite angles, which means if these opposite angles are congruent and they bisect each other, then all four of these angles are congruent. Now you could use the traditional congruent tick marks. I like to just put four of the same colors, four of those matching color dots there, and I think that's a little easier to read. The other thing then is that these opposite angles are congruent, so I can put matching color dots on those four angles as well. I just think that's a little easier to read than trying to match all of the little tick marks, but some of you will probably like that. Do make note of this little note here that angles 1, 2, 3, and 4 are congruent to each other, and 5, 6, 7, and 8 are congruent, but we can't mix and match, okay? So 1 isn't congruent to 5. I do want you to also maybe give yourself a little highlighting of one of these triangles, because every triangle in here is going to be a right triangle. And we know that whenever we have right triangles, we're going to have some sneaky Pythagorean theorem in there. All right, now let's take a look at our squares. This is the most special of all of our parallelograms. So of course, it's going to have all the parallelogram properties. Oops. Let's see if we can clean that up a little bit there. Oops, that's not what I meant. Okay, don't worry about it. It's all the parallelogram properties. A square is also going to be a rectangle, so it's going to have all the rectangle properties. I'll talk about how to mark this in a moment. And it's going to have all the rhombus properties because it's going to be a rhombus. So our square incorporates all of our properties. So let's talk about how that helps us. So if it's a parallelogram, these opposite sides are going to be parallel. A square by definition, has 4 right angles and 4 congruent sides. This means that it is a regular quadrilateral because it has the congruent sides and the congruent angles. So we're going to mark our congruent sides with our nice single tick marks, and we're going to mark our 4 right angles, and then we're going to look at how we can add some additional properties. If all 4 of these sides are congruent, it's a rhombus, and we just saw that a rhombus should have perpendicular diagonals. Okay? We also saw that if it's a rectangle, because it has these 4 right angles, these diagonals should be congruent. Well, if the diagonals are congruent and they bisect each other from our rectangle properties, then all of these individual pieces are also congruent. Now, that means that when we look at any of these triangles, not only are they going to be a right triangle, like we had in the rhombus, but they are in fact going to be a 45, 45, 90 triangle. So all of them are going to be that. All of these angles here are going to be 45 degrees. So every angle in the square is either 45 degrees or 90 degrees. We could also, as we saw earlier in the semester, we can also find this triangle here, which is also a 45, 45, 90 triangle. Where the hypotenuse is going to change, so you have to pay attention to that, but just keep that in mind that every triangle in a square is one of our special right triangles. So we will always want to remember that extended ratio that we used for our special right triangles. Okay? We will work and extend this and look at how to apply it when we are in class.